Hello friends, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about UV visible spectroscopy. You can see this instrument is a UV visible spectroscopy. So what is the mechanism behind it? This is the source, this is entrance slit, dispersion device, exit slit. This setup is monochromator, this is sample, this one is detector. Now spectroscopy, it is the branch of science that deals with the study of interactions of matter with light, or it is the branch of science that deals with the study of interactions of electromagnetic radiation with matter. Now electromagnetic radiations. Electromagnetic radiation consists of discrete packets of energy which are called as photons. A photon consists of an oscillating electric field E and oscillating magnetic field M, which are perpendicular to each other. So look at this picture, see the magnetic field. This is the source of directions and this is the electric field. Both are perpendicular to each other. Now friend, electromagnetic radiations. You have to define the frequency. Frequency, it is defined as the number of times electrical field radiations oscillates in 1 second. The unit of frequency is hertz, 1 hertz 1 cycle per second. The another important parameter is lambda. It is the distance between two nearest parts of the wave in the same phase. The distance between two nearest crest or troughs is called wavelength. Electromagnetic radiation, this is the wavelength, this is the amplitudes. Relations between wavelength and frequency can be written as C nu lambda. As photon is subjected to energy, so E is equal to h nu is equal to C by lambda. So these are the electromagnetic radiation range. Electromagnetic radiation, white light goes through a prism forming dispersion angles, and this is the violet, indigo, blue, green, yellow, orange, red range. Now principle of spectroscopy. Principles of spectroscopy is based on the measurement of a spectrum of a sample containing atoms or molecules. A spectrum is a graph of intensity of absorbed or emitted radiation by sample versus frequency or waveform. The spectrometer is an instrument designed to measure the spectrum of compound. Absorption spectrum, spectroscopy, an analytical technique which is concerned with the measurement of absorptions of electromagnetic radiations. UV 185 400 nanometer, visible 400 to 800 nanometer spectroscopy, IR spectroscopy have different range. Principle of spectroscopy, emission spectroscopy, an analytical technique in which emissions of a particle or radiation is dispersed according to some property of the emissions. The amount of dispersion is measured, example mass spectrometry. Interactions of electromagnetic radiation with matter. Interaction of electromagnetic radiation with matter, electronic energy level. At room temperature, molecules are in the lowest energy levels. When the molecule absorbs UV visible light from electromagnetic radiation, one of the outermost bond, lone pair electron, is promoted to higher energy states such as E1, E2, is called an electronic transition, and difference is as E is del E is equal to H now. En minus E naught, where N is equal to 1, and energy is this amount. Now vibrational energy level, these are less energy level than electronic energy level. The spacing between energy level are relatively small. When higher radiation is absorbed, molecules are extended from one vibrational level to another. It vibrates with higher amplitudes. So rotational energy level, these energy level are quantized and discrete. The spacing between energy level are even smaller than vibrational energy level. You can see the electronic energy is higher, the vibrational energy is less than the electronic and greater than rotational, and less one is rotational in out of these three. So now Lambert's law. When monochromatic radiation is passed through a solution, the decrease in the intensity of radiation with thickness of the solution is directly proportional to intensity of the incident light. Let I be the intensity of incident radiation, x be the thickness of solutions, then minus d by dx directly proportional to I. So di by dx is equal to ki. Integrate equation between limits I is equal to I naught and x is equal to 0, I is equal to I and x is equal to 1. We get ln I by I naught minus k. Lambert's law 2.303 log I by I naught minus ki. Log I by I naught is equal to minus k by 2.303, where log I naught by IA absorbance, k by 2.303 k absorption coefficient, and A is equal to EI Lambert's law. Now Beer's law. When a monochromatic radiation is passed through a solution, the decrease in intensity of radiation with thickness of the solution is directly proportional to the intensity of the light as well as concentration of the solution. Let I be the intensity of incident radiation, x be the thickness of the solution, c be the concentration of solutions. Then di by dx directly proportional to ci, so di by dx kCa. Integrate equation between limits I is equal to I naught at x is equal to 0, I is equal to 1 at x is equal to 1. We get I by I naught kCl. So 2.30 log I naught by kCl. Log I naught by I is equal to k divided by 2.303 Cl, where log I naught by I is equal to absorbance, k by 2.303 E molar extension coefficient, A is equal to ECl, Beer's law. So Beer's law AECl is equal to I by I naught or minus log d log I by I naught A. From the equation it is seen that the absorbance, which is also called as optical density OD of a solution in a container of fixed path length, is directly proportional to the concentration of solutions. What is the principles of UV spectroscopy? The UV radiation is an extent from 10 nanometer to 400 nanometer, and the visible radiations is an extent from 400 nanometer to 800 nanometer. Near UV regions 200 nanometer to 400 nanometer, far UV regions below 200 nanometer. Far UV spectroscopy is a study under vacuum conditions. The common solvent used for preparing sample to be analyzed is either ethyl alcohol or hexanes. Now friend, UV visible spectroscopy already show you. So I hope this video will be helpful to you. If you like this video, then don't forget to subscribe my channel. Thanks for watching.